It's volume time, okay? Now we're gonna start talking about three-dimensional solids. So if we're looking at a figure, then a flat side is called a face. Okay, so there's a face on this side, the top is a face, the bottom is a face. Polyhedrons are shapes that have 4 or more faces, and each one being a polygon. So this face is a square. This face is a rectangle. This face down here is a triangle, but the bottom face is a square. So these are polyhedrons, okay? And some polyhedrons are cubes, prisms, and pyramids. We're gonna start by talking about solids with rectangular bases. So cube, the volume is just going to be the side cubed. In a cube, all of the sides are the same length, all the faces are the same square. And in general, if you have a figure that's kind of straight, you can just take the area of the face and multiply it by the height. So the area of the bottom is s squared, multiplied by the height is also s, and that's how we get s cubed. Rectangular prisms are very similar. It's straight. So we can take the area of the bottom, which is width times length, multiply it by the top, height, and that's where width times length times height comes from. And lastly, but not least, pyramid is no longer straight, right? It's angled. So this my logic doesn't hold anymore, but we'll have 1/3 the length times width times height. Remember that 1/3 for the pyramid. It's gonna kind of come back later. So let's use these formulas. One note before we go on, just as area was measured in feet squared, inches squared, meters squared, volume now is 3-dimensional. It will be cubed, feet cubed, meters cubed, etc. Okay? So find the volume of a cube with side length 6 meters. We don't have to even draw a picture. We could, it'd probably be helpful, but we could just use the formula. The formula under cubes just said it's the side length cubed. Well, our side length here is 6 meters, so that's just going to be 6 cubed. And if you type that into a calculator, you should get 216. Our units are going to be meters cubed because it's volume, 3-dimensional. A lot of people, myself included, think better when we have pictures. Also, a lot of people, myself included, draw terrible pictures, but you can draw a cube kind of like this. This is not going to be a drawing class because, again, I'm a terrible artist. My cube is a little crooked, but this is kind of what it looks like. Each side is going to be 6 meters long, so we can label it like so. And it's kind of a crooked little cube, but we'll pretend it's not crooked. One more example for this video, and then we'll be done. This week will be a shorter week than a lot of weeks, so enjoy it. Find the volume of the shape below. One thing to point out here. If you remember, the formula for a pyramid like this is, hold on, I want to use the same letters that we used. It was 1/3 length times width times height. Note that the height is from the middle of the bottom to the top. This length right here is not the height. Just like when we had a triangle, right? When we had triangles, or even better yet, right? A triangle like this. Remember that this was the height, not this. This is not the height. This is some other side. Similar with pyramids. So watch out for that. So this is just going to be 1/3. It doesn't matter which one of these you call length and which one of these you call width. You get to choose. So I'm going to say 4 times 3 times the height, which is 8. Everything's in the same units, which is good. Multiply these together, and you'll get 12 times 8 is 96 thirds, which approximates to, oh, it equals something exactly, actually. 32, I think. It equals No wavy signs, no approximate signs. It is exactly 32 feet cubed because we are talking volume. Happy face. Okay, so go ahead and have fun.